Alright, so throughout this chapter we've been talking about surface area and volume of various geometric solids. And here we finish up our set of notes with pyramids that have a regular polygon for a base. So we've already talked about prisms with a regular polygon base. This is going to be very similar to that, just modifying it, of course, with our pyramid formulas. So in all of these situations, we will be given a polygon that is a regular polygon that will be stated in the directions on any exercises we do. We don't typically mark them on the diagram just because of the amount of kind of clutter that creates. So for this one, we are looking at a pyramid with 1, 2, 3, 4, 5, 6, 7, 8 sides. So we have an octagon. All right, let's start by drawing our little isosceles triangle. Remember, these represent 2 radii of this base. In this case, those are the radii. And then this represents the side of the polygon itself, the side of the octagon. So let's deal with what we're given here. We're given from the center to a vertex 10 units. So center to vertex, that's our radius of 10 units. Now we draw in the height, which remember is the apothem of the polygon, which is going to allow us to find its area, and its perimeter will be determined by this little right triangle here. All right, now we need the angle measure up here at the vertex angle. So we take 360, divide it by the number of sides, in this case 8, which gives us 45 degrees. Take that angle, remember that's the entire angle here, 45 degrees. We want half of that. So we'll divide it by 2 to get 22.5 degrees. And that's the measure of this angle here, 22.5 degrees. Okay, so to find the length of the apothem is the adjacent side, the 10, of course, the hypotenuse opposite that right angle. So in this case, adjacent and hypotenuse means a cosine function is useful. So the cosine of 22.5 degrees equals the adjacent over the hypotenuse. When we multiply both sides by 10, we get 10 times the cosine of 22.5 degrees equals the apothem. So we'll use that in a moment when we're ready to find the area of the base itself. Now, the other thing that we need to find before we can find the area of the base is the perimeter of the base. And to do that, we need the length of this little segment x. Once we have the length of that segment, then the length of the side of the polygon will be double that x value. So x is opposite the 22.5 degree angle. 10, of course, is the hypotenuse, which tells us a sine function is useful. So we take the sine of 22.5 degrees equals the opposite x over the hypotenuse 10. Multiply both sides by 10. And we find that x is 10 times the sine of 22.5 degrees. Now remember that x is half of the side length. So the entire side of the base will be double this length. And when we double it, we double the coefficient, we don't double the angle. So the side length in this case will be 20 sine 22.5 degrees. And that gives us enough information to find the perimeter of the base. So we have 8 sides, each 20 sine 22.5 degrees long. 8 times 20 tells us the perimeter is 160 times the sine of 22.5 degrees. Okay, so we've got the perimeter of the base. Now let's find the area of the base. Scoot my paper up here. The area of the base, since it's a regular polygon, is given by 1/2 times the apothem. Remember, the apothem is what we found up here. 10 cosine 22.5 degrees times the perimeter. Whoops. Perimeter is 160 sine 22.5 degrees. So let's see, half of 10 is 5. 5 times 160 gives us 800 times the cosine of 22.5 degrees times the sine of 22.5 degrees. Now we have our p value, we have our b value. In order to find the surface area, we need the lateral, or the slant height, and for the volume we need the height. Now in this case the height is 17. We know it's the height because it extends from the vertex to the center of the base. And in this case, the slant height would come from this vertex down the center of the side to the midpoint of that base edge. And remember, the distance from the center to that base edge, that's our Apothem value. This, of course, would be our slant height L. So in this particular case, h squared plus a squared equals L squared. H is 17. A squared, remember our A is up here, 10 cosine 22.5 degrees will equal L squared. So L is simply the square root of this quantity. Now I went ahead and squared the 17. You don't necessarily have to do that. You could leave it as 17 squared if you so desired. That's our 289. Alright, so in this case we now have B, P, H, and L. And we're ready to find the surface area and volume. So surface area, area of the base plus 1/2 times the perimeter of the base times the slant height. In this case we're taking this 800 cosine 22.5 degrees sine 22.5 degrees plus 1/2 of the perimeter, 160 sine 22.5 times L, which is this square root. So in that case we end up with. Now remember, when you type these into your calculator, anytime you open or start a trig function, it's going to open a set of parentheses. So remember to close the parenthesis after the 5 each time. Oops. Typed in the wrong angle. That wouldn't work. 289 plus. Now here you want this quantity in parentheses as well. 10 cosine 22.5. Close that parenthesis, squared. And then in my case, when I open the square root, I have to close the parenthesis again. And that gives us a value of 810.92 units squared for the surface area. For the volume, which is a little simpler in terms of what we have to substitute, 1/3 times the area of the base times the height. So in this case, we're taking 1/3 of 800 cosine 22.5 degrees. Dang it, that decimal and I today are just having issues. Sine 22.5 degrees. And we multiply it by the height, which was 17. So our volume in this case, 1/3 of 800 cosine 22.5 sine 22.5 times 17. 1602.78 units cubed. And that takes care of finding the volume. Now you can see that these are a little more work involved, partially because of this having to make sure we have both H and L in order to find the surface area and volume. And that finishes up our notes on surface area and volume of various geometric solids.